Hello, and welcome to Dear Android, the show previously known as Android Developer Office Hours. We got a bit tired of developers always trying to show us up by asking us questions we couldn't answer every week, so we decided to try a new format for a change. We'll be selecting the best Android application development questions from across the internet, including Google+, and answering them for you here on YouTube. If you're watching us live, which is every Wednesday at 2 p.m. Pacific, we'll be hanging around for a few minutes after each episode to answer any questions about the current episode. So, with that out of the way, let's go ahead and move on to this week's question, which comes from Dancio on Stack Overflow, who's a user from Poland. He asks, if I have a custom service that I'm broadcasting via Bonjour, and that I'd like to either broadcast or discover using Wi-Fi or Bluetooth, is this possible on Android? To answer this question, we have Alex Lucas, who's a member of our Android Developer Relations team, who wrote many of the docs about both network service discovery and Wi-Fi on our developer site. Alex, could you help us answer this question?
Absolutely. So to break the question into two subparts, will Bonjour-like services work on Bluetooth and will they work on Wi-Fi? The answer is yes on Wi-Fi, no on Bluetooth. Thank you for tuning in. That's our show.
See you, Alex.
Bye. So we should actually probably answer this question in a little bit more detail. To start with the Bluetooth part. Bluetooth is a really great protocol for lots of device-to-device applications like streaming music or communicating with heart rate monitors. But on Android, it does not actually support TCP. So what that means is you cannot create a TCP socket and connect to it over Bluetooth to other devices. Because network service discovery, or at least the Android implementation of network service discovery, run over TCP, this creates a fundamental incompatibility between Bluetooth and TCP. That said, it does actually work over Wi-Fi.
Alright, so before we go into a bit more detail, let's give a bit of background about what exactly NSD is. So NSD is Network Service Discovery, which is Android's implementation of multicast DNS, using the DNS-SD, so DNS Service Discovery protocol. And what this does is it allows applications to broadcast their existence on the local network, along with connection details for that application, to any other devices in the same proximity, which would be any other devices, again, on the same local network. So this is useful for things like social applications, games, or even network services like printers or web servers. So that way you can find what devices are nearby.
When NSD broadcasts this information over the network, there's four fundamental pieces of information it's going to send over. One of them is the device identifier. The device identifier is often going to be either the user's name or the device host name. Another item is going to be the service name. The service name is often going to be the name of the application. For instance, if you have a game called Replica Island that you want to play with other users over the network, and Replica Island has network service discovery built in, the service name is probably going to be something like Replica Island. Another item is going to be the host address, which you don't actually have to enter yourself at runtime. Android will just figure that out for you and send that along in the NSD packets. The final item is going to be the port. And I wanted to make a special note about the port, which is that for mobile applications, the easiest thing to do when you're designing the game or the application is not actually to pick your own port at runtime or hardcode one in. What you want to do is get a server socket and set it to port 0. And what that's going to do is it's going to tell the Android framework, just give me whatever port is available on the system. When the server socket returns the port number to you, you then enter that port number into the network service discovery broadcasts. The handy thing about this is that if you, for instance, had decided that you wanted port 53 to be the one your application runs on, and some other application developer decided that they wanted port 53 as the one that their application runs on, there would never be a conflict, and there would never be an issue where the user had to choose between your application or someone else's application running at any given time.
Right, and this is a nice side effect. It means you don't have to request a reserved port from the IANA.
Right.
Now, you do still have to go and register your service name, but it's as simple as just filling out a simple form, and the chances of there being a conflict are pretty much non-existent.
Yeah, very small. You don't actually need the IANA reservation for when you're doing internal testing, but as soon as you let your application out onto the internet to roam free, it's a really good idea to get it registered.
Yes, it's just good practice.
Yeah.
Right? Now, we talked a bit earlier about Bluetooth, and even though you can't use NSD on Bluetooth, there's another answer that we want to give you, a better answer, and that's called Wi-Fi Direct. Wi-Fi Direct is a peer-to-peer version of Wi-Fi, so it lets devices communicate with one another without having to go through an access point. This provides many of the same benefits as Bluetooth, device-to-device connections, but with the advantages of Wi-Fi, which means increased speed and increased range. This is available on devices running Android 4.0 or above, that's
Ice cream sandwich.
and if you happen to be running Android 4.1, Jelly Bean, you also get service discovery. Now, unlike the traditional case of network service discovery, which we just addressed, Wi-Fi Direct service discovery will work even when you're not connected to a network. So think about that for a second. Devices running your application nearby can be detected even if they're not connected to the same network as you. That's pretty cool.
Yeah. What my favorite thing about that, what that basically means is if you're in a movie theater waiting for the previews to start, let's say you gone to the midnight showing or something like that, you have an hour to kill, you can open up the application and see who else in the theater or in line is playing the same game you are and connect to them and play a game, having no idea who they are.
Right, it gives you physical proximity.
Right, physical proximity, which is awesome because you know that the movie theater is not going to have a Wi-Fi network there.
Yeah.
And they're probably, a lot of them these days actually are designed to block incoming calls and signals and stuff.
Yeah, but please don't use that as an excuse to play the game during the movie.
Right, don't play during the movie. There's lots of helpful previews that tell you that's just a bad idea and it's rude and there would be a bright screen and in front of the people behind you. And we're not suggesting that. But when you have time to kill in line or before the previews, knock yourself out. Now, we do want to point out that it's still important to implement network service discovery for when you're connected to a network. There's a couple reasons for this. One of them is that Wi-Fi Direct is not going to work at all when you're connected to a network because of the way the underlying technology works. You're either connected to a network or you're surfing around for Wi-Fi Direct devices. The other item is that there are a lot of services and hardware that broadcast services that are designed to be discovered on a network. Examples of this are network cameras and network printers. Now, most companies will not set up their network printers to be Wi-Fi Direct accessible because that means anyone who is within physical proximity who didn't necessarily have permission to use that printer could print out whatever they wanted. So being on the network and requiring the user to be on the network provides a sort of permission system or just a small layer of security. So really your best option is to implement both Wi-Fi Direct and NSD, and that way your application will have the best of both worlds and increase the chances of your users being able to connect to each other no matter what circumstance. In order to use Wi-Fi Direct service discovery, the necessary class that you want to use is Wi-Fi P2P Manager, which provides an implementation of DNS-SD similar to the way standard NSD does. For more information about how to actually implement network service discovery and service discovery over Wi-Fi Direct, we have a training class available at developer.android.com/training. And we really recommend you go there and read through the tutorial. We also provide some sample code, and it walks you through a real-world example of how to implement this functionality in a pre-existing application.
Right. And if you have any questions about either NSD or Wi-Fi Direct, join us via Hangout after the live broadcast, where we'll be able to help answer those questions for you. All right? And if you have any questions for next week's broadcast, post them to Stack Overflow or send them to us via Android developers at Google+, and we'll pick the best of them for next week's broadcast. All right? And with that, we'll see you all next week. Thanks for joining us.
Bye, guys.